Hello, welcome to another sprint from showing Evernym's contributions to our open source foundations, Hyperledger and the Sovrin Foundation. Before we get started, I want people to know that Hyperledger has moved is moving away from Google Docs into the Confluence Wiki, and they migrated from the old wiki to the new wiki. And we started to put more information there as well. We moved all of our sprint demo plans into the wiki. So this page lets you see all of our historical sprint demos. And if you're watching this video, then you know where our YouTube channel is, at the Evernym channel on YouTube. And in that Evernym channel, there's a Hyperledger plus Sovrin playlist that has all these videos. And so you can come in and see what we've been doing over time. There's about a year, more than a year at this point, of videos that you can review. And you can search by topic that's interesting to you. So that should make this material more easily accessible to people. So today we're going to talk about what we completed, looking at the sprints. On the SDK side, we mostly did polish, completed a release at the end of May, and improved some of the standards, did some bug fixing, things like that. On the Indy-Node side, again, we completed the release of the Audit Ledger and the Auth rules, and got all that deployed on to the Sovrin networks, which is fantastic. We did find a bug. We're going to talk about what caused that bug and how we've addressed it. And and then we started our progress towards the end of June release, where we're going to improve the way request handlers are managed. For token plug, the Sovrin token integrates with Indy-Node as a plugin, and so we want to improve the way that plugin interface works so that the token can be more reliable and easier to maintain. So we've made good progress on that over the last couple of weeks. And then on the Sovrin token side, similarly, we've focused on getting the auth rules improved and starting to integrate some of the token. The new approach to requests from plugins. And we added more integration tests to libsoft token. So that's a summary of what we completed this sprint. With that, I'll stop sharing my screen and let Sergey discuss the problem we found on BuilderNet and how we solved it.
Hello, let me share my screen. I hope you can hear me. Do you see my screen?
Looks good. Yep, thank you.
Great. So I'm going to talk about BuilderNet incident, what caused it, and what we've done to fix this thing. First of all, why this happened in the first place. We had a recent edition of Audit Ledger, and this ledger, among other things, contains aliases of current primaries. So when primaries change, Audit Ledger adds a new record about new primaries. And on the BuilderNet, one of current backup primaries was demoted. And but however, no view change happened after that, and this was the first problem. So this is part of the bugs that led to BuilderNet incident. It happened so that now Audit Ledger contained a list of primaries, one of which with one of those primaries no longer being a validator node. And if there was a view change for some other reason, then everything would be good. However, before that view change, nodes were restarted and started a catch-up procedure. And a catch-up procedure works like, well, it has a Audit Ledger check in the end, and this check is very enthusiastic about throwing exceptions when it finds some inconsistencies. And this is the second part of the problem, because after throwing an exception, node restarts, starts the catch-up, catch-up finds inconsistency and throws exception again. So we are stuck in a infinite restart loop. So that's why the pool went to the inoperable state. To remediate this problem, we are in the process of releasing a hotfix. There are two important fixes in these hotfix. One of them is that we changed exceptions. We removed throwing exceptions and started just loading about errors which are actually recoverable, and this inconsistency in Audit Ledger list of current primaries is actually a recoverable error. And another part of this fix is that we now force a view change when backup primary is demoted. Before, it was forced only when demotion or promotion changed F number of nodes. So, for example, if we had 4 nodes, added 1 node, for example, if we had 6 nodes which could tolerate just one fault, and then we promoted a node, so we now have 7 nodes which can tolerate 2 faults. So only in such cases a view change was performed, which updates Audit Ledger. Now it's performed also when some of backup primaries are demoted. And in order to apply this hotfix, we need to perform a manual upgrade. So it means that while we cannot send the pool upgrade transaction because pool is down, so this upgrade should be performed manually. That's all from me.
Excellent, appreciate that. When we discussed this as a team, I thought there was something about an invalid replica. Did I remember that wrong, or was there an invalid replica for the demoted node?
I'm not sure about this. Well, all replicas were valid. Just one of them was demoted.
Okay. And that's why it got stored in the audit ledger, is because it had a replica even though it had been demoted.
Yes, it was a backup primary, then it was demoted, but Audit Ledger wasn't updated. And then sanity check started throwing exceptions, and these sanity checks happen among other things on the startup. So node cannot start up.
So we continued maintaining a replica for that backup primary even though it had been demoted.
We don't maintain it. It's just recorded in the Audit Ledger, and we expect it to be a validator node, but it's no longer a validator node, and this makes the sanity check throw an error.
Okay, that makes sense. I was trying to translate the way Alex explained it to me to your analysis, and that makes sense. Okay, part of it was me misunderstanding, so that's good. Thank you for that review. And the hotfix release is it approved for release already, or is it still have some additional testing?
Well, I believe it's already released. It successfully passed a lot of tests. It successfully passed upgrade tests, and as far as I know, it passed most of system tests, automated system tests that we have. Andrew K can provide some more details.
So yes, we are running additional system tests, and mostly they are passed for now. I'm ensuring that all tests are passed. I hope testing. So we will end testing in a few hours, I think.
Excellent. And so then it's up to the Sovrin Foundation when they are ready to upgrade BuilderNet, and they're going to have to coordinate with the stewards for that manual upgrade. So thank you very much for that update. Next, we want to talk about the auth rules improvements in the SDK, and I include some changes in Node. So Sergey, you're welcome to share your screen.
Yeah, thank you. So it really affects both Indy-DK and Node spots. So I'm going to tell about 3 updates. 2 of them are affected both Indy-Node and Indy-DK, and 1 of them only for Indy-DK user experience changes. And the first one is now we are allowed to set multiple auth rules at the same time. It's implemented on Indy-Node and now supported in Indy-DK and Indy-CLI. It makes a process to set up pool more convenient and more atomic. The second change is implementing a forbidden constraint. Now we are able to totally forbid some action. For example, we can forbid any changes of existing schema. And the third small update is renaming of trust anchor role to endorser. This only for libindy and CLI, so only for SDK API changes, because between Indy-Node and libindy, in this communication, just some predefined numeric constant is used. So I'm going to show all these changes from CLI point of view, but all of them are applicable for libindy API too, as well. So let me create some wallet pool configuration and use it. I have my developer pool on my machine, and there is predefined trust on it on this ledger. So I'm going to use it. And here's the first change. Now we can specify endorser role, and it's just replacement for trust anchor. For backward compatibility, libindy API and CLI supports also trust anchor, so there is no reason to update applications immediately. It's still libindy still accept old naming, but in output it will be shown as endorser, as you can see here. It's the first change. So now I'm going to switch to endorser wallet and show some activity around auth rules. Okay, here's my new endorser. It was published to the ledger on the previous step. And now I'm going to use this DID and establish connection to the pool. So now I'm requesting current permissions on the ledger to operate with schema. As you can see, and here is a default policy. By default, schema can be added by trustee, by steward, or by endorser, renamed from trust anchor. And schema are forbidden to the edit. So let's try some examples around that. So I'm using my endorser and going to post new schema. It's successfully posted. I can post one more schema. This is the same name, but different version. It's different item from ledger point of view. So we can check that both entities are successfully posted to the ledger by read requests. And we have first version of the schema with only one attribute, and second version of the schema with 2 attributes. And if I try to change these schemas, for example, I try to change attributes in this first version of schema, the transaction will be rejected by the ledger because the default policy to forbid any changes in the schema. So it's true for any schema on the ledger for now. And we can double check that it's really not changed on the ledger. So we can see initial version of the schema, only 1 attribute for the first and 2 attributes for the second. And now let me switch back to the trusty, predefined trusty, and change the policy. So the old policy is allowed addition of schema and forbidden editing. And now I'm going to change it in opposite situation. Just for example, I don't think it's a real use case, but it's, I think, very good an example. So now we can send auth rules, multiple auth rules at the same time. And now I'm sending 2 of them. The first one is to forbid the adding new schema. So after that, auth rule will be applied. No one new schema can be written to the ledger. And the second change is allow edit existing schemas, just for an example. So these new auth rules are posted to a ledger and successfully accepted by it. So we can double check the current state. And now we have a forbidden edit and allowed addition by owner of a schema. And let me illustrate the new permissions. So now I'm operates from trusty, and if I try to create a new schema, this request rejected because our new policies. But if I switch back to endorser, I will be able to edit my existing schemas. So I'm trying to add one more attribute to the first version of the schema, and it's successfully added. And also I can change the second version of my schema. And you can see that here are new sequence number in the ledger, transaction sequence number in the ledger. We can just double check it by read request and see the similar output. So I think that's it from my side. Thank you.
Excellent. That's going to be really useful to restrict actions as needed on the Sovrin network. So thank you for showing that, Sergey. Last item today is Nikita is going to take us through our main focus for June, which is the refactoring the way the Ledger plugins are handled.
Sorry guys, seems I can't stop my sharing because of Zoom problem. I have to kill my Zoom.
I think
make Nikita able to. Oh, thank you, Richard.
Richard, I have a question. Have we done some intro or previous demo for request handlers, for pluggable request handlers?
Yeah, so this is, thanks for reminding me. We started this work last November, and you can, people that want to look at the video from December 20th, Sprint 1825, can get some intro on request handlers. So we don't have to review that today, but we put it aside. We got the audit ledger out, we got the multi-signature out, we got the token working, and now we're coming back to finish that work that was started long ago. So I'm glad to, thanks for the reminder, Nikita.
Yeah, so I'll start then. I will give some kind of quick intro about the request handlers for some for persons who don't know what is it about. So what we wanted to implement. We want to implement
Nikita, where can people find this diagram?
Oh, this diagram can be found on in Indy-Node repo. I'll post the updated version that I have here. So it differs a little bit from the one that is in repo, but this one has some more additions. So, what is pluggable request handlers? We wanted to avoid the inheritance in the design of transaction and batch handling, because it caused a lot of errors, and as a concept it is really error prone. So what we decided to do, we decided to split all of our process of transaction handling into three main ways. So I did something wrong, I think. My Zoom crashed. Oh, I need to rejoin, I think.
Maybe if I remove your screen share,
Yeah,
you can.
yeah. Let's get remove my screen sharing. Oh yeah.
Okay.
Yeah, works. Thank you. Share screen.
No. Oh yes, it came back.
Yes,
Excellent.
it came back. So, what's next? So what we did? So we have like write request handler, read request handler, and batch request handler, and action request handler. So write is for write transactions, read for read ones, action for action transactions, and batch handlers is for handling batches on the stage of three-phase commit. However, it's not only for the transactions. When some when some processes need to happen along with, for example, new transaction, like updates of IDR cache, we make a new handler. So in IDR cache handler, you'll find only the updates of IDR cache, and the same goes on the stage of batch handling. So we implemented the same thing in the token plugins. Right now, it's only in soft token, and soft token fees are coming right now. So what we have three types of handlers here, because we don't have any actions in token plugins. We have write requests like mint and xfer. We have read ones like getUtXO, and we have batches. Then I will show what was before that. So there was a big long file with a lot of things that you needed to support and know about all of these connections between the functions and so on. It was really hard to get into and to recognize what's going on and where it'll go next. Moreover, you should always you should have always kept in mind that it is also inherited from some other class that has its own functions and its own functionality. Maybe you'll need to get to super methods and so on. Right now, what we achieved, it looks like that. So when we go to the mint, we just know that there is some static validation. Then we have some dynamic validation. Here it's only things from auth rules, and some short things to update state. And the super methods are needed only to work with some storages, some states, and some ledger things. What it was for xfer, it's not really. It's a little bit bigger, but also it's manageable, and it became much more error prone. So that's what we achieved through these big refactoring, and I think we still need to integrate it and test it, but it should be much easier to fix new issues and bugs with this approach. That's it.
That's excellent. Glad to see it's excellent architectural refactoring to go through and simplify things that way. So thank you for everybody who worked on that. We do expect this to be done at the end of June. And in order to do that, we have to keep the team very focused. We won't be doing as much on the SDK side. There are some vacations and holidays in June. And so the current plan for the next sprint is keep working on this. And then and on the SDK side, we want to start talking about we're going to dust off that architecture we've been talking about SDK 2.0. As part of that, we want to incorporate like what is the future of Aries and how does Aries relate to Indy? What is the future of libvcx and the Indy SDK? We need to answer some of those questions. We're going to work on that over the next couple of weeks. And we've also starting to add the PBFT view change. So we've talked for a year about how the way view change is handled doesn't exactly match the way the paper suggests, and there are some known issues with it. And so by implementing PBFT view change, we're going to be able to make that more robust. And we want to get that done. We'll get token handlers, plugin request handlers out this month and work on PBFT view change next month. So, and get it out hopefully in August. So that's the idea there as far as sprints go. After that, we can start thinking about long-term items again. We recognize the need for DID docs. We need to think about how to get that done. And we want to work on the new approach to schemas that Brent at Evernym and Ken at the Sovrin Foundation have been working on with the W3C. So we want to see if we can get those done before the end of the year. And we're reserving a chunk of time to do bug fixing. So that's the idea for the next few sprints. With that, we'll end this meeting. We'll come back. We'll post another video in about 2 weeks with more results. You can see our backlog in the wiki. Remember that each video has a sprint number, and that maps to the sprint number in Jira. So that'll help you. If you're ever in Jira and you see an issue you're interested in, that sprint number will map to a video. So it makes it easy for you to find information that'll help you as you get to know Indy. So with that, thank you to the team. You're making excellent progress. Appreciate all your professionalism and work, and we appreciate the collaboration we have with contributors across the Indy community and now the Aries community. So thank you.